In this lesson, we're going to learn how the definite integral is related to area. So the first thing to note is that a definite integral does not always relate to an area of a region. But if our function that we're integrating is continuous and non-negative on a closed interval, in other words, the function is at or above the x-axis, then the region that is bounded by the function x equals a, x equals b, and the x-axis has an area that corresponds to the definite integral from a to b of f of x. So what we're saying is, notice that this function f, this blue curve, is above our x-axis. And we have the line x equals a and x equals b and our x-axis. And so this region has an area that corresponds to the definite integral. Notice the lower limit of integration corresponds to this left boundary. The right boundary corresponds to the upper limit of integration. And our function, f of x, is our integrand. So in a later section, we will learn how to evaluate these using the fundamental theorem of calculus. But since we don't know that yet, we can use geometry. To use geometry, let's first graph our function. It's important that whenever we are finding any area, we must first graph our region. So we have y equals the square root of 9 minus x squared. Now I want you to notice that this is the principal square root. So therefore, y is not negative. It's above or equal to 0. That's important because of what our next step is. If we square both sides, we get y squared equals 9 minus x squared, which means that we have x squared plus y squared equals 9. Now the whole reason that we did this is because I'm betting that we had some difficulty knowing what the graph of this function looked like. So by applying this little trick of squaring both sides, I can see that this is a circle of radius 3. And it's centered at 0, 0. So let's go ahead and graph this function. So here we have our circle of radius 3 centered at the origin. Now why did I not draw the bottom half of this circle? And it goes back to the fact that y has to be bigger than or equal to 0. So our curve must be at or above our x-axis. Now look at the limits of integration. The limits of integration are from x equals 0 to x equals 3. So if we look at x equals 0, it's the vertical line through the origin, and it's also known as the y-axis. And then x equals 3, and then because our function is not negative on this interval from 0 to 3, then we know that the definite integral corresponds to the area under the curve between the x-axis and the curve. So if we look at our x-axis, then what is the region we are trying to find the area of? So the region that is bounded by the curve, the x-axis, and these two limits of integration is the shaded region, which is a quarter of a circle. So the area of the whole circle, we know, is given by the formula a equals pi r squared. So we only need a fourth of that. So the integral from 0 to 3 of the square root of 9 minus x squared dx is going to be, in this case, 1/4 of pi times the radius squared. So we get 9 pi over 4. So now let's look at this integral. This definite integral is the integral of y equals 2x plus 1. This is a tad bit more obvious in terms of what its graph is. No special tricks are needed. So if we graph this, we should just obtain a line, and the slope is 2, and the y-intercept is 0, 1. So let's go ahead and graph that. So there is our line. And if we look now at our limits of integration, we have the limits of integration are given by x equals 1 and x equals 2. So let's draw the corresponding vertical lines on our graph. X equals 1, x equals 2. And now if you'll notice, our function isn't negative on the corresponding interval. So therefore, the definite integral will correspond to the area under the curve, but above the x-axis. So if we look at our x-axis, and we shade now the region bounded by these 4 curves, what do we get? We obtain a trapezoid. And we know the area of a trapezoid. So let's go ahead and evaluate our integral. The integral from 1 to 2 of 2x plus 1 dx is equal to, and now the area of a trapezoid is the sum of the bases, and the bases are the parallel portions of this trapezoid. So this base is 3 units, and this base is 5 units. So if I add those together, I have 3 plus 5, and divide by 2, and then I multiply by the height. And the height of this trapezoid is 1. So this integral evaluates to be 4.